Students, as we have discussed yesterday, vector product and cross product. The thing is, the definition of cross or vector product says it's a vector quantity. Its applications mainly we find out in finding the vector perpendicular to the plane containing A bar and B bar. And meanwhile finding the perpendicular distance from a line to the plane, and finding the vector areas of a curve. Now, after knowing the A cross B is equal to mod A into mod B into sin theta into n cap, A cross B is a vector whose magnitude is a product of three positive real numbers. That is mod A, mod B, sin theta. It's a product of three positive real numbers. Into n cap. Why n cap? You know already. The direction of A cross B is always along n cap. Therefore, A cross B is always parallel or collinear with n cap. Parallel or collinear with n cap. So therefore, one vector can be expressed as scalar multiple of another vector. That is, I can write this one as A bar cross B bar is equal to mod A bar mod B bar. It's a sin theta into n cap. A bar cross B bar is equal to mod A into mod B into sin theta into n cap. So now, after knowing this, we went for a geometrical interpretation of dot product as a area of a parallelogram with the adjacent sides A bar and B bar. We have found out the area of the triangle with sides A bar and B bar as half into modulus of A bar cross B bar. We found out the area of a parallelogram with diagonals A bar and B bar. Let us recall the definitions of a vector or a cross product in detail. What is that? Is what note says, if A bar, B bar are non-zero vectors, A bar, B bar are non-zero vectors, L, M, B3, B be the scalars, means real numbers, then first one is minus A bar cross B bar is equal to A bar cross of minus B bar is equal to minus of A bar cross B bar. Next, the second one is minus A bar cross of minus B bar is equal to A bar cross B bar. Then the third one is, that is LA bar cross MB bar is equal to LM into A bar cross B bar. Let us give an interpretation to these 3 points. One is minus of A bar cross B bar, A bar cross of minus B bar is equal to minus of A bar cross B bar. Now, your book is a white plane. My board is a white plane, correct or not? Blackboard is also plain. If I take this point, if I take this a line, right? This is a plane. Or else, if you want to take like this, instead of this plane, this is A bar, this is B bar, and theta is the angle between them. So therefore, this is nothing but minus A bar, this is nothing but minus B bar. Therefore, angle between A bar and minus A bar minus B bar is theta. What about this? This is 180 minus theta. This is 180 minus theta. This is also a plane. In the plane, we have considered the two vectors A bar and B bar. So for A bar and B bar is theta is the angle. For minus A bar minus B bar in the negative direction is also theta. Meanwhile, 180 minus theta is also an angle between what? That is minus A bar B bar. Meanwhile, A bar comma what? Minus B bar. If I apply the what? Vector product. If I apply the vector product, that is A bar cross B bar is equal to mod A into mod B into what? Sin theta into n cap. If I define A cross B, now this is nothing but what? A bar cross B bar will be like this, and n cap will be perpendicular to the plane containing A bar and B bar. Yes, with this what? Angle between the two vectors. Let us start the proof of this one is. What's the proof of this one is? Look here. Let case 1. Let A bar comma B bar be two parallel vectors. Parallel vectors. When they are parallel vectors, it is quite obvious. Then minus A bar comma B bar are parallel, and A bar comma minus B bar are also parallel. When any two vectors are said to be parallel, cross product is equal to what? 0, which implies A bar cross B bar is equal to 0, minus A bar cross B bar is equal to 0, A bar cross of minus B bar is equal to 0. Therefore, we have proved, which implies A bar cross B bar is equal to minus A bar cross B bar is equal to A bar cross of minus B bar. We have proved this condition. Followed? Let us see what? When A bar and B bar are non-parallel vectors. A bar and B bar are what? Non-parallel vectors. Now this is when A bar comma B bar are non-parallel vectors, then minus A bar comma B bar and A bar comma minus B bar are also non-parallel vectors. Non-parallel vectors. Okay, in this case, we have to show that these three are equal. So now, for A bar cross B bar is equal to mod A into mod B into sin theta into n cap. A bar cross B bar is equal to mod A mod B into sin theta into n cap, where n cap is the unit vector perpendicular to the plane of A bar comma B bar. Then A bar comma B bar comma n cap. A bar comma B bar comma n cap forms a right-handed system. Right-handed system. So therefore, now coming to for minus A bar cross B bar is equal to mod A mod B minus of A bar into sine of angle between minus A bar and B bar into n cap, n1 cap. So therefore, now I can write where n1 cap is the unit vector perpendicular to the plane of minus A bar comma B bar. Then minus A bar comma B bar N1 cap are in right-handed system. Right-handed system. Then for A bar cross of minus B bar is equal to A modulus of A bar minus of B bar into sine theta, that is sine of angle between A bar comma minus B bar into N2 cap, where N2 cap is the unit vector, perpendicular to the plane of A bar comma minus B bar. Thus, then A bar minus B bar comma N2 cap are in right-handed system. Yes, for A bar cross B bar, we have shown they are in what? Right-handed system. I mean A bar comma B bar comma N cap forms a right-handed system. For this also right-handed system. For this also what comma right-handed system. Since the plane generated by A bar comma B bar minus A bar comma B bar, A bar comma minus B bar are same. When they are same, certainly A bar comma B bar comma N cap are in right-handed system. Minus A bar comma B bar comma N1 cap is also in what? Right-handed system. Then A bar comma minus B bar comma N2 cap is also in what? Right-handed system. Therefore, we can write N cap is equal to N1 cap is equal to what? N2 cap. N cap is equal to what? N1 cap. N cap is equal to what? N2 cap. So, therefore, what I do is the plane generated by A bar comma B bar and minus A bar comma what? B bar, A bar comma minus B bar are same. Then A bar comma B bar comma N cap minus A bar comma B bar N1 cap and A bar comma minus B bar comma N2 cap are in right-handed system. Right-handed system. It means that all are in what? Right-handed system. Let us see how they are what? Equal. So therefore I can write A bar cross B bar minus A bar cross B bar is equal to minus A bar, that is a B bar, into sine of 180 minus theta into N cap, N1 cap. So therefore I can write, so minus A bar cross B bar is equal to minus A bar, it's a B bar, it's a sine theta into minus N cap. So therefore since N1 cap is equal to minus N cap, so therefore I can write minus of A bar cross B bar is equal to, take this minus outside, this is minus of A bar, this is what? B bar, sine theta into what? N cap. This is nothing but minus of A bar cross B bar. Similarly, we can prove A bar cross of minus B bar is equal to A bar minus B bar into sine of 180 minus theta into N2 cap. since n2 cap is equal to minus n cap, so therefore I can write a bar cross of minus b bar is equal to a bar. This is what? Minus b bar. This is plus, it becomes sine theta into what? Minus n cap. So therefore a bar cross of minus b bar is equal to minus of mod a mod b sine theta into n cap. So therefore this is nothing but mod, that is minus of a bar cross b bar. Yes, we have proved minus a bar cross b bar is equal to minus of a cross b. Similarly, a bar cross of minus b bar is equal to minus of what? A bar cross b bar. So therefore, hence we have proved this identity. Now similarly, you can go for the what? Second one. Minus of a bar cross of minus b bar is equal to, I can write this one as minus of a bar cross of minus b bar, and meanwhile, that is, this becomes minus of a bar cross b bar. This becomes what? A bar cross b bar. So hereafter, minus a bar cross of minus b bar is equal to what? A bar cross b bar. In the same fashion, we can go for LA bar plus MB bar is equal to what? LM into what? A cross B. When L and M both are positive, when L is negative, M is positive, L is positive, M is what? Negative. When both are negative, we can prove LA bar cross MB bar is equal to what? LM into what? A bar cross B bar. Right? Now next one is vector product with respect to vector addition satisfies the distributive law. That is, a bar cross of b bar plus c bar is equal to a bar cross b bar cross c bar. Let us see. For this, the proof is, let r bar be any vector. Now consider r bar dot of a bar cross of b bar plus c bar. Now dot and cross are interchangeable. Now if you consider this one is, I can write r bar cross a bar dot of b bar plus c bar. I can write this one as r bar cross a bar dot b bar plus r bar cross of a bar dot c bar, which implies I can write this one as r bar dot of a bar cross b bar, r bar dot of a bar cross c bar. Now what is there? R bar dot of a bar cross b bar plus c bar is equal to this. Take it to what? LHS. Therefore, r bar dot of a bar cross of b bar plus c bar minus r bar dot of a bar cross b bar minus r bar dot of a bar cross c bar is equal to 0. So therefore, now I can write r bar dot of b bar plus c bar minus a bar cross b bar A bar cross C bar is equal to 0. Whenever the dot product of any two vectors is equal to 0, which implies A bar cross of B bar plus C bar minus A bar cross C bar is equal to 0, which implies A bar cross of B bar plus C bar is equal to A bar cross C bar. So therefore, this is the what? The vector product with respect to vector addition satisfies what? Distributive law. Now, again, so let R bar be any vector. Consider this, take the dot product of this. It can be written as dot and cross are interchangeable. Now, R cross A dot B bar plus C bar, R cross A bar dot B bar, R bar cross A bar dot C bar. So therefore, R bar dot of A bar cross B bar, R bar dot of what? A bar cross C bar. So therefore, now once again dot and cross are interchangeable. R dot of, that is R bar dot of A cross B, R bar dot of A cross C. So therefore, now you get it to what? LHS, and take the vector, what vector? R bar is a what? Common. R bar dot of this. Whenever the dot product of any two vectors is equal to 0, they are either perpendicular or one of the vector must be equal to what? Null vector. This is equal to 0 or this is equal to 0. So therefore, this is equal to 0. Hence, we got it. A bar cross of B bar plus C bar is equal to A cross B plus what? A cross B. A cross C. Vector product of unit orthogonal vectors. Vectors I, J, K. I, J, K. Now coming this one is, let us start. I cross I is equal to dash. Now, I cross J is equal to I cross K is equal to, let us find out. Now, if I take this one as X, Y, this is Z, this is I, this is J, it's a what? K. Let us take X axis denoted with what? I, Y axis with J, Z axis with what? K. So therefore, I cross I, mod I into what? 0 degrees into n cap. Now, for I cross J is generated along what? K cap. K cap is also unit vector. This is the unit vector which is perpendicular to the plane containing I and J. So therefore, now by using this one, instead of n cap, I take what? K cap or K. Okay. So therefore, I can write this is sine 0. Angle between the same vector is what? 0. Therefore, it becomes what? 0. Then I cross I is equal to 0. Next, I cross J. The angle between X and Y axis is what? 90 degrees. Therefore, mod I, mod J, sine 90. The vector which is perpendicular to I and J is what? K. So therefore, instead of this one is, I can write this one as, I can write instead of K, you take this as n cap, let it be. So therefore, this is what? K. Now I can write, it's a 1, it's a 1, it's a 1 into K bar is equal to K. So what we proved? I cross J is equal to what? K. Next, I cross K. I cross K is equal to I, next what? J, next what? It's what? Sine 90, but it is in what? In this direction, I cross K. So therefore, it becomes what? Minus J. So therefore, I can write this one as I cross K is equal to what? Minus J. So therefore, I can write this one as, it's a X, I, J, K, I, J, K. I cross I 0, I cross J, K, I cross K minus J. Next j cross I minus k, j cross j 0, j cross k what I, k cross I, that is k cross I, it's a j, k cross j, it's a minus I, k cross k 0. So therefore this is nothing but the vector product of unit orthogonal vectors I, j, k. Okay, unit vector product of unit orthogonal vectors I, j, k is what? I cross I, you see, I cross I is equal to 0, I cross j is equal to k, I cross k is equal to minus j, j cross I is equal to minus k, j cross j is equal to 0, j cross k is equal to I, k cross I is equal to what? J, k cross j is equal to minus I, k cross k is equal to what? 0. Always take it into consideration, I is nothing but x-axis, y, that is j is nothing but y-axis, k is nothing but what? Z-axis. Therefore, angle between x and y 90, y and z 90 is, z and what? X is what? 90 degrees. Maybe in clockwise direction, maybe in what? Anti-clockwise direction. Means same direction and opposite direction. So therefore, you take into consideration I cross j, I, j, sin 90, it's a k. I cross I, sin 0, it's what? N cap. You take it as, instead of what? K, you take n cap. N cap is what? Unit vector. Since angle is what? 0, therefore it becomes what? 0. Whatever the unit vector you want to write. Okay, there is no restriction, you have to write what? N cap, you can also write anything. So therefore, now I cross j is equal to k, we proved, and I cross k is equal to what? Since it is in opposite direction, so therefore it goes in a what? Common clockwise direction, it becomes what? Minus j. Unit vector perpendicular to I and k in a opposite direction. Therefore, I wrote it as a minus j. So hereafter, I cross k is equal to minus j. Here also, I cross k is equal to what? Minus j. So therefore, this is the concept of vector product of orthogonal unit vectors. Next one is, if a bar is equal to a1i, a2j, a3k, b bar is equal to b1i, b2j, b3k, then a bar cross b bar is equal to I, j, k. This is a1, a2, a3, b1, b2, b3. a1, a2, a3, b1, b2, b3. Let us see how you get this one is. Now the proof of this one is very simple. A bar cross b bar is equal to a1i, a2j, a3k cross of b1i, b2j, b3k, b3k. So therefore, take the cross product a1i with each and every, this one is a1 into b1 into I cross I. Next, a1 b2 into I cross j. Next, a1 b3 into I cross k. Right? Plus, I'll go to this one is plus this with this one is a2 b1 into j cross I, a2 b2 into j cross j, a2 b3 into j cross k. Right? Next, a3 b1 into k cross I, a3 b2 into k cross j. Next, a3 b3 into k cross k. Right? Just now I told vector product of orthogonal unit vectors, I cross I is equal to what? I cross I cross I is equal to what? 0. This is 0. Now next, this is 0. Next, this is 0. And meanwhile, I cross j is equal to, now I cross j, j cross I is there, correct or not? You have to write minus I cross j. So therefore, minus I cross j is equal to j cross I. Next, coming to what? Come on, I cross k is equal to minus k cross I. Next, next one is k, that is k cross j, j cross k is equal to minus k cross j. So now you write it. So therefore this becomes a1 b1 I cross j common, a1 b1 into here minus a2 b1 into I cross j, here it comes as minus, okay, minus, next plus, next j cross k, here a2 b3 a2 b3 into here minus common j cross k, that is a3 b2 into j cross k, next k cross I a3 b1 minus a1 b3 into k cross I. Yes, now this is nothing but a1 b1 a2 b1 into k, next a2 b3 a3 b2 into I, next this is nothing but a3 b1 a1 b3 into z. So therefore this is nothing but the value of the expansion of the determinant I j k, a1 a2 a3 b1 b2 b3. So therefore hereafter now a cross b is equal to the det, the first row is I j k, second row a1 a2 a3, next b1 b2 b3. This the value of the determinant is nothing but a cross product. This is valid when now the base vectors are I j k. If it is other than I j k, this expansion, this value of the determinant is not valid. You have to go by either this way or in other way. I'll explain to you. If P bar is equal to L1 into A bar, L2 into B bar, L3 into C bar, Q bar is equal to, yes, M1 into A bar, M2 into B bar, M3 into C bar, where P bar comma Q bar are expressed as a linear combination of base vectors A bar comma B bar comma C bar, then P bar cross Q bar expressed as B cross C, C cross A cross B. This is L1, L2, L3, M1, M2, M3. Earlier what I told is in terms of I j k. Now it is in terms of what? A bar, B bar, C bar. They are not what unit vectors. It is expressed as a linear combination of base vectors A bar, B bar, C bar. Then what to do? Now the solution of this one is, okay, the solution of this one is start P bar cross Q bar. Now L1 into A bar, L2 into B bar, L3 into C bar. Next M1 into A bar, M2 into B bar, M3 into C bar. Now this is nothing but take cross product this with this with this with this. So therefore L1 M1 into A bar cross A bar, L1 M2 into what? A bar cross B bar, L1 M3 into A bar cross C bar, plus this with cross product L2 M1 B bar cross A bar, L2 M2. B bar cross B bar. Next L2 M3 into B bar cross C bar plus L3 M1 into C bar cross A bar, L3 M2 into C bar cross B bar, L3 M3 into C bar cross C bar. This is equal to 0, this is equal to 0, this is equal to 0. Meanwhile, that is A cross B is equal to what? Here B cross A is equal to minus A cross B. That is next, that is C cross A is equal to minus, okay, A cross C. Now this is what? B cross is equal to minus of this one is. I can write L1, yes come on, L1 M2 minus L2 M1, here A cross B. Here I wrote minus A cross B. Next B cross C, L2 M3, L3 M2 into B bar cross C bar. Here. So therefore, here L3 M2, you change it. Next, L3 M1 minus L1 M3 into C bar cross A bar. This is same as the value of the determinant. The value of the determinant. What is that? B cross C, C cross A cross B, L1, L2, L3, M1, M2, M3. This is how you can expand A cross B when P bar, that is, you can expand P bar cross Q bar when P bar is X P bar and Q bar are expressed in terms of A bar, B bar, C bar, right? A bar is equal to, if A bar is equal to, or else A bar cross B bar is equal to mod A into mod B into sine theta into n cap. Now I want to find out that angle between the two vectors. I want to find out the angle between the two vectors by using the sine theta. So therefore, what is sine theta here? It's a vector quantity. Angle is a scalar quantity. Take the modulus on both sides. Modulus of A bar cross B bar is equal to mod A into mod B into sine theta into modulus of n cap. Modulus of n cap is equal to 1, which implies that is modulus of A bar cross B bar by mod A into mod B is equal to what? Sine theta. This is the angle between the what? Two vectors by using what? Cross product. Cross product. Right. Now coming to, if A bar comma B bar are non-zero, non-parallel vectors, then modulus of A bar cross B bar whole square is equal to mod A whole square mod B whole square minus A bar dot B bar whole square. This is same as A dot A, A dot B, A dot B, B dot B. Right? So this is one of the important property in the what? Vector product. This gives the what? Correlation between vector product and a dot product. So therefore, what I do is, the proof of this one is, by definition of cross or vector product, A bar cross B bar is equal to mod A mod B sine theta into n cap. Followed? So therefore, A bar cross B bar is equal to mod A mod B sin theta into what? N cap. Now squaring on both sides. Okay. Now you can take, or else modulus you can take it as a place. It makes no difference. Why? We know it already in the what? Dot product. A dot A is equal to mod A whole square is equal to A bar square or A square. We call it as. You can square, otherwise you can take the modulus. Later you can square on both sides. So therefore, A bar cross B bar whole square is equal to mod A whole square mod B whole square into sine square theta. Followed? Now I can write mod A whole square mod B whole square. I can write this one as 1 minus cos square theta. Expand this bracket. Mod A whole square mod B whole square minus mod A whole square mod B whole square into cos square theta. Into cos square theta. So therefore, I can write mod A whole square mod B whole square. This is nothing but mod A bar mod B bar into cos theta whole square. Later, I can write this one as modulus of A bar cross B bar whole square is equal to, that is mod A whole square mod B whole square. This is A bar dot B bar whole square. Now, we have proved that's what modulus of A bar cross B bar whole square is equal to mod A whole square mod B whole square minus A bar dot B bar whole square. Enter, this is nothing but I can write, so now A bar dot A bar B bar, that is A bar dot B bar, next A bar dot B bar, it's a B bar dot B bar. How? What is A dot A according to this? Mod A whole square. This is A dot B. This is A dot B. This is mod B whole square. If you want, you can expand it, you see. This is nothing but, how to get this from this one is mod A whole square. It's A dot B. This is A dot B mod B whole square. Expand it. This becomes mod A whole square mod B whole square. This is A bar dot B bar whole square. So therefore, instead of writing like this, I wrote directly here. So therefore, what we proved is, once again, A bar cross B bar is equal to mod A mod B sin theta into n cap. Now take the modulus on both sides. I made it as a scalar quantity and the squaring on both sides. Meanwhile, modulus of n cap is equal to 1. Now, what is sin square theta? 1 minus cos square theta. Expand is 1 into this into this. Mod A whole square mod B whole square cos square theta. This is mod A whole square mod B whole square minus mod A mod B cos theta whole square. So therefore, this is nothing but by using the definition of dot product. That is mod of A cross B whole square is equal to mod A whole square mod B whole square A bar dot B bar. In turn, this is nothing but det of or determinant of A dot A, A dot B, A dot B, B dot B. How this is equal to, this means I have shown by using this property A dot A is equal to mod A whole square. This is what? Mod B whole square. Expand it. Once again, you are getting the previous result. It has much applications while doing the what? Problems. Now let us recall the what? This concept for the what? Example. How? If modulus of A bar is equal to 5, modulus of B bar is equal to 6, modulus of A bar dot B bar is equal to 24, then modulus of A cross B is equal to dash. Now what I do is, by using this result, I can write this one as modulus of A bar cross B bar whole square is equal to mod A whole square mod B whole square A bar dot B bar whole square. Now this can be written as modulus of A bar cross B bar whole square is equal to mod A whole square. It's a 5 whole square. It's a 6 whole square minus 24 whole square. Now this is nothing but A bar cross B bar is equal to 25 into 36. It is 24 whole square. Simplify, that gives the what? Exact value of what? Modulus of A bar cross B bar whole square. Followed? So therefore, we come across about what hereafter? Modulus of A bar cross B bar whole square is equal to mod A whole square mod B whole square minus A bar dot B bar whole square. Thank you.